Hello, everyone. In this video, we will give a guide and tips for chapter 21 of the Java book. Chapter 21 introduces sets and maps. In Java, we have three kinds of sets: hash set, linked hash set, and tree set. In the previous chapter, we introduced lists. Lists, you have the notion of index. You have the first element, the last element, and 10th element. But in a set, there's no such notion of index. And the elements in the set are non-redundant, so they are unique. So this, we have three kinds of sets: a hash set, a linked hash set, and tree set. Let's look at the hash set. So here's the hash set, and it's a non-duplicate. There's no any particular order. So here, if you create a set, so this is a hash set, and you add the elements into set, and when you display it, it's not in any particular order. So you display, so you add this London, Paris, New York, San Francisco, Beijing, New York. So they're displayed in here, San Francisco first, Beijing next. And also you notice that you added New York 2 times, but only one New York is displayed. So there's no duplicate, and they're displayed in any, can be in any random order. So you can traverse the elements in the set and using iterator, and you can use explicit iterator or use the for loop or for each loop. Now, linked hash set, you can insert the elements in the insertion order. So this is to maintain the order. So this is linked hash set. So here's the linked hash set, and you can see that it's London, Paris, New York, so in this order. And the tree set is you use the comparator and to specify and how you're going to compare the elements in this tree set. Here's the tree set. You create a tree set and using another set. And now when you display it, you can see that it's in the alphabetic order. Now you can specify a comparator, and you can compare them in any order you desire. All right, so here in this section, to compare the performance of sets versus lists, and sets are very, very efficient, as you see. And so this is, if you have a bunch of data you want to put in a data structure, you don't care about the order, you have no duplicates, you can use just the hash set. It's very efficient. All right, so here's example here, counting the keywords in a Java source code file. So you have a Java source code file and counting the keywords. So you can look at, you get all this Java source and all the words and see if there's any of this, their keywords. So this is, we use the set. We create a set of keywords, and you're going to test if this and keyword set and it contains. So the keyword set, and here keyword set and contains, and this word. So this is the word. And you read the word from this file, the Java source code file. So this is very efficient. We're going to look at the efficiency of the big O notation in this next chapter. It's order of 1 times constant time for detecting whether a word is in the set. All right, so now let's look at the map. Map is a data structure, and you have the entrance. So we call it entrance. And each entry is actually a pair of 2 items, the key and the value, so the key value. So in this example, we have a map, we have social security number and the name. So the names and the social security number, so this together, it's a form of an entry. So it's called a map, is you use the key to find the value. So this data structure is also called a dictionary in Python, and this hash table. So this is because it's implemented using hash table. So the map is the term we use in Java. So similar to the set, we have a hash map, a linked hash map, and tree map. So this is the common features in the interface of map. And so those are the concrete three classes: hash map, linked hash map, and tree map. So the methods here and how do you insert an entry. So using this put, and how you retrieve value from the map using the get, using the key. So this here. Now here's a case study, and to find the occurrence of words. So you have a word from a file, or we just simplify it and put this in a text. So you find out, and so here how many times good appears. So it's case just insensitive. So they're all the same. Good in uppercase G and lowercase g is the same. So there's 3 good. So all the other. How do you write this code? If you don't have data structure, you're going to write up a lot of code. And here, using the data structure, you can simplify code and writing very efficient code. All right, so this last section in this chapter, singleton and unmodifiable collections and maps. So you can create the collection with a single element, and you can collect the create a collection, and that's not modifiable. All right, so that is all for this chapter on sets and maps. Thank you for watching. Goodbye.